Stay tuned, everybody. I'm actually here. Just running a little late. If there's anybody here. Just running a little late. If there's anybody watching, that is, because I can't even tell right now. I'm going to head to the PC. You all right? Hold on. All right, we're back early. Ha. All right. Do we have people here? What's going on? How is everybody, if anybody's there? Checking the chat now. Trying to get myself in. All right. Anybody who's watching, give a holla. Hi, Action Jackson and Brian Spence and Dick Dusher. Nice name. Classic. All right. All right, we're looking at the odd anomalies. Can anybody point out the odd anomalies in the magnetosphere? It's freaking a lot of people out. Can anybody comment on how many people are watching right now? I don't think I can see it. Yeah, so what we're looking at here is a bow shock. This is the, let's see, this is the pressure. You're looking at two different views. Over here you're looking at from the equatorial plane, and here you're looking at the meridional plane. The left side shows you dusk and dawn. The right side shows you north and south. And you can see how this is very skewed. This is like a 20-degree angle on this system here. And to a lesser degree, there's a similar kind of a connection between the magnetotail. 15, 20, some people say 24 or 23 degrees. Unfortunately, I haven't personally been watching this since this began. And we've heard two different accounts, one that it occurred on November 10th, the same time that we had that strange earthquake that made, quote, the earth ring like a bell, which is a bit of a misnomer. But it did cause a weird radio frequency to kind of bounce around the whole planet. And so, anyway, this has been persistently like this for, well, according to the accounts that the most credible account since December 3rd. I'm still in the process of trying to track down data that I can get archived data on this. Sorry we were late in starting the stream, but I had to go for a run, so I didn't feel like crap. By the way, everybody, there's a cosmic ray alert going on right now, and we covered it in today's regular video. And we went to these cosmic ray sites. So check out this one. This is a great site. It's a Russian site, but it's got links to a ton of cosmic ray monitors. So we opened up a few of those to see what was going on. And here's Athens. This cosmic ray spike wasn't as big as what we saw around December 2nd, but you can see there was a very dense spike today, actually. That's actually, considering the trough to the crest of that most recent waveform there, that's the biggest change we've had since probably the 8th, or the 7th rather, and the highest overall since the 2nd. You know, we'd like to see this go down, as perhaps that's a precursory indication that cycle 25 has started, where we're going to see more sunspots and less zero sunspot days. Here we are, the Mexico City Cosmic Ray Observatory. Same deal, and it looked like it would level off. Check it out today. Looked like it was going to level off, and then it went back up more. Again, that's Mexico City. Here you have Moscow. Please stop saying Moscow. It's pronounced Moscow. And no, we don't have any business dealings with them. Hello, Colo John. Is it Colo Jan or Colo Jan? Collagen. And Ernest Martinique. Let me know if I mispronounce your names. I'll probably forget how to pronounce them by the next time I see you. We were going to talk about Sagittarius A-star, but we found the cosmic ray stuff more interesting. So let's just bypass that and talk about how cosmic ray intensity is involved with solar cycles. Okay, anyway. So, those of you who watch the channel regularly, I'm sure you're aware that Oh man, my head is itchy. I'm sure you're aware that there's a inverse proportional relationship between number of sunspots and amount of cosmic ray flux. And here's an article on Principia Scientific. So, there's your cycles. You can see the most recent very strong cycle was all the way back in 1970 or so. And here's the last 3 years. Keep in mind this is not quite as high as it was in 2009, but it's approaching those levels. And you can see here, this is the lowest amount of exposure that astronauts could handle, occurred around 2009. That was the highest cosmic ray flux that we've ever measured in the space age. It's now currently almost that high. The fact that it doesn't seem to be going higher is kind of a good sign. We're hoping that we don't see higher levels in 2009, because if that's true, we will end up with an even weaker cycle. Some people are predicting a stronger cycle 25. Some people are predicting a weaker cycle 25. And why are cosmic rays so important? Well, people think climate change causes clouds to form differently, and it's the clouds forming differently that causes the climate change, not the other. So here's an article from Henrik Svensmark of Sweden. This is talking about the variation of cosmic ray flux and global cloud coverage, which is totally crucial because cosmic rays cause more clouds to form in the lower troposphere, which many people misidentify as chemtrails. We find it very, very important to understand the science here, in that the cosmic rays are the crucial aspect, not even the aerosols. Also, more aerosols get in the atmosphere at times of solar minima, and that's via volcanic eruptions especially. And here's a link to Perspecta Weather. I don't know what I was looking at there. Let's look at your geospace perturbations. I know the live stream isn't as compact, but I'm getting this data for myself right now too. So let that load. There's North America. Keep in mind, this is a model created by taking many measurements by the University of Michigan Geospace Department. And the magnetosphere is quite charged. The geospace rather, it's pretty charged. Got some anomalies there, hitting Alaska, stretching all the way down to the Pacific Ocean as they were yesterday. Not at a super strong scale, but nonetheless. Let's look at the global version of the same map. Same measurements, rather. I'll let that one play through. So you can see the field extending all the way out into this area from the south and way down here in the north. I'll let that play through again. This is kind of what you would call the ground map of the map that we started out with there. So this is the effect on the ground in between the sun and, whatever part of the planet's being connected. It's magnetic. And then lastly, see the poles? By the way, these are not extremely powerful spikes, but they're pretty diffuse, meaning they're kind of all over the place, just not super strong. Thank you, Ernest. We really appreciate you watching. We didn't expect to even get to 200 subscribers. So we were surprised when we got to 130, and then we were really surprised when we got to 260. And then we went so fast from 260 to 700 plus that I couldn't even make a 500 subscribers video. Since I get up at 3 o'clock most mornings, it's beer o'clock. Looks like we only have one viewer on Twitch.com, and it's me. That's cool. So anyway, just wanted to share that little addendum there. And also, that's what happens when you go running on trails when it's 26 degrees, folks. You cough and hack. Let's just head to spaceweathernews.com real quick and look at this data here. Give me the desktop site, yeah? By the way, we endorse Brave Browser, as it is not a Google product, and it is not specifically designed to track you. If you'd like to do a web search, we recommend DuckDuckGo.com. Little tiny X-ray flux. There you go, a little X-ray flux. Not even in the B range. We got a phi angle signal, tiny little signal on the sun, and then going back to the Earth to Sun connection. So just a little spike there. You can see the solar wind is still about where it was when we did this morning's video. Some spikes that look like cosmic ray spikes on the Discover again. You see those? Those little flat spots. Those look like cosmic ray spikes, or they could be what we call a CCD bakeout, when the charge coupled device turns itself off to avoid being destroyed. Magnetometer, extremely erratic. We have like a sputtering connection to the incoming coronal hole, I'm quite sure. So KP is at 1. Fortunately, the solar wind speed's high enough to not go back to 0. Because if we got a KP of 0, we could have a historic cosmic... a historic cosmic ray flux spike. Electron flux rising as expected. And there's your F2 ionosphere layer. Now, let's tie this together with what we were looking at the beginning. Now, you see that? So the sun is going to be located in front of this. Right about here. All right. So as the sun charges up this part of the planet, this part slowly becomes charged again, and this part slowly becomes discharged. The magnetotail comes out the other side of the planet, while the charge comes in this side of the planet. Does that make sense? Let's go back to those geospace magnetosphere models. Because again, we really want to reiterate here that this is anomalous and that this totally coincides with the heliospheric current sheet, which right now is like this. At a similar and a much higher pressure at the other side. Let me just show you one more model here real quick. Go to Solar Ham. So that you understand how these things all relate. And believe you me, they do. All right. This is the best one for this. Now, there's a lot of stuff on here. Just focus on the middle pane. This is all you really need to talk about. You see this little streamer, this little white streamer here? That's the heliospheric current sheet. This referring to it as the current sheath. And here's your interplanetary magnetic field line. The proportional ratio between those has a massive effect on the bow shock. As time goes on, Earth occasionally passes on either one side or the other of this heliospheric current sheet. Either the sheet moves or the Earth moves or both. And that affects how that forward part of the magnetosphere works. So understand that. And lastly, understand that this is showing you North Pole versus South Pole. And you can actually see it fluctuating right in this area. And that is all caused by the relationship between the interplanetary magnetic field and the heliospheric current sheet. Now, this left pane, this actually shows you each planet's magnetotail. And this is why planetary alignments are marginally important in the flow of plasma through the solar system. Because as you can see, these things react with each other a little bit. And that's my best hypothesis on why you've got this strange angle in the magnetosphere. We can't rule out the possibility that it's caused by some sort of changes inside the Earth. But we can see the changes outside the Earth, and that's science. All right, so I'm going to have to get off of here because I got to go eat food before I croak. So thanks, everybody, for tuning in. We're going to be monitoring this regularly now. And have a nice day. Remember, when you're driving, don't drink. And if you drink, don't drive. Oh, and just another little side note for all you people that tuned into my live stream. The reason that we always state that we don't want people to drive is because I'm a pretty serious cyclist. In 1999, I was racing at the regional pro mountain bike level. And our sponsor is the Velo Shop, who has nothing to do with these broadcasts. Although if they ask us for a weather forecast, we'll give them a hell of a concise one that will be accurate enough to know what time it will rain on each side of the mountain. Don't forget to hit theveloshop.net for all your cycling needs. All right, folks, seriously, thanks for tuning in. Don't drink and drive. Share the road. And remember, some cyclists like me are professional drivers as well.